So we're picking up on problems that will require us to use our unit circle. It says evaluate without the calculator. So 20, the tangent of pi over 4. So from your unit circle, what is the tangent of pi over 4?
1. What were you going to say?
I was going to say 1. I just couldn't get there in time.
Well, you say you're so close. It's like,
Because
what, were you going to say the wrong answer?
I made it the cover of my notebook, but it's like for the notebook, they made it where like all the regular papers are like barely fit. It's like a struggle just to look at it.
That's funny.
There, Virginia.
All right, 22, the secant of pi over 3. Now, that value, like we didn't write secant values on our unit circle. We could have, but it just gets a little excessive. But what does secant go with? Cosine. So we can think about this as 1 over the cosine of pi over 3. And what is the cosine of pi over 3?
Root 3 over 2.
Cosine of pi over 3.
1/2.
1/2. So this is 1 over 1/2, which keep, change, flip would make it 2. So the secant of pi over 3 would be 2. (24) The cosecant of pi over 3. So what does cosecant go with? Sine. So this is going to be 1 over the sine of pi over 3. And what's the sine of pi over 3?
Root 3 over 2.
Root 3 over 2. So 1 over root 3 over 2. Keep, change, flip is going to make it 2 over root 3 or 2 root 3 over 3. Now these next ones crack me up just a little bit because they say evaluate using a calculator, give an exact value, and then they proceed to write the answers like this. Your calculator will not produce that. So it's a known value, we don't need to use our calculator. If it's something weird, like say it was the sine of 93 degrees or something, yes, you would use your calculator, but I think all of them are known, like would be known values, so I don't understand, whatever. All right, 26, the sine of 60 degrees. So what would that be?
Root 3 over 2.
Root 3 over 2. Let's see, 28, tangent of pi over 3.
I was looking right at it and I could not figure out the word. I was like sitting there I was just staring.
I'm waiting for you to go.
Well, I'm like, I couldn't.
Like this thing.
I know. I was like, I see a 3. I just can't figure out what to say. The weird looking division thing. I was like, I'm gonna get this one, and then right as I was about to say it, he said,
I'll let you get the next one.
"Thank you."
Riley, you take it.
What? No. Don't.
Go for it, Riley.
All right, we have some that are evaluate using a calculator now that actually need a calculator. I think they have the wrong instructions, to be honest, under that last set of problems. But typically when I do these, I'm going to just lump them all under the same instructions of like solve or like evaluate using a calculator only if necessary or something like that, meaning like if it's a value that we don't know. So something like 32, see if y'all can figure what we need to do with this one. Tangent of 23 degrees, 42 minutes.
Conversion.
Okay, how are we going to do that?
Virginia.
Convert minutes to degrees.
Okay, what's my conversion for that?
Is it just like the number over 60, or is that something else? Oh.
Because 60 minutes is 1 degree.
Okay.
So, yeah. So once you get that decimal, you just...
That's like 0.7.
0.7.
Should be anyways.
So then we would take the tangent of 23.7 degrees. Now, they caution you to be sure your calculator's in the correct mode because some of these are going to be in radians and some of these are in degrees. So this one's degrees, so make sure you're in degree mode.
Do we have to have the degree symbol in the calculator?
No.
How much did you say to round up to?
They go to 3 decimal places in the book, so we'll just do that.
0.449.
Alright, I'm going to see if y'all can figure this one out. Secant of 1.24. Anyone?
3.079.
Yeah, I definitely should have said it. I got 1.000.
What mode are you in?
Degree.
I'm in radian.
But what is this?
That's
It's a radian. There's no degree symbol.
I always mess that up.
Okay, that's why I wanted you to do that because I wanted you to realize, like, if the degree symbol is not explicitly there, it's in radians.
Okay.
Now, I think if I had told you, you would have known I need to change my calculator, but I was trying to see what you would do without me telling you. All right, now, I guess, are we good with plugging stuff, like, other than that situation, are we good with plugging stuff into the calculator? Okay, because obviously there's some that are like the sine of pi over 15 or the cosecant of pi over 10, things like that. Those aren't known values, so those have to be plugged in, obviously. This is really irritating me. There's a loose string on my sweatshirt. Give me 1 second.
I had one on mine too.
Don't understand. Okay. So, let's see. Next thing. Find the acute angle theta that satisfies the given equation. Give theta in degrees and radians. You should do these problems without a calculator. So, we've got 42, which is the sine of theta is equal to root 3 over 2. So basically we're working backwards in these, which is kind of like what we did last year, but we did them as inverse functions because essentially that's what we're doing. We're taking the inverse sine of that to get the angle. But these are known values, so we don't really need to do that. We're just trying to think what angle theta gives me the sine that's equal to root 3 over 2, basically, which is, like I said, it's essentially an inverse, but anyways.
Do we want it in degrees or radians? Or both?
It said both.
Okay.
And
Virginia,
it's
go.
acute angle theta. So let's keep that in mind as well.
Stop in Virginia.
All right, so what theta value is, or like what is theta when the sine is root 3 over 2?
This Virginia. Go for
Wait,
it.
is it the degrees?
Both. I
Oh.
want degrees and radians.
60 degrees pi over 3.
Yep, 60 degrees, pi over 3.
Saw that?
Yes, I was watching.
I just got it right.
I'm so proud.
Cosine of theta is equal to root 2 over 2.
Degrees or pi over 4.
45 degrees, pi over 4. .46 cotangent of theta is equal to 1.
Virginia, go. It's really easy.
Yes.
45 degrees or pi over 4.
45 degrees or pi over 4.
It's really easy.
Okay, because cotangent is the same as 1 over tangent. Okay, so we were just looking for 1 over where is the tangent equal to 1, basically. And then that's how we got that. So basically this was where is 1 over the tangent of theta equal to 1. And so we needed tangent of theta equal to 1 to make that one work. I think we're good on those. Solve for the variable shown. So in these ones, they're going to give you a triangle. And they are right triangles. They tell you that this angle is 39 degrees. This side is z. And this side is 23. And they want you to solve for z using the information that you know. Now, all of these ones will be in degree mode with your calculator. You will have to have your calculator. You can't just solve these by hand randomly. So, what trig function associates these 3 pieces of information that I have? Or 2 pieces that I have and 1 that I don't.
Cosine.
Cosine. So we're going to have the cosine of 39 degrees is equal to adjacent over hypotenuse, so 23 over z. And then with z being on the bottom of that fraction, I can just swap z and the cosine of 39. And so I'm going to have z is equal to 23 over the cosine of 39 degrees. So if you had switched to radian mode, make sure you switch back.
How far do you want us to go out with the rounding?
Where did the... I don't know how far they went. Just 1 decimal place is fine.
29.6.
29.6. .52. Got this angle down here is 43 degrees. Side is x and this side is 14. Which one should I use for this one?
Okay, Virginia.
Sine of 43 degrees is opposite over hypotenuse, so x over 14. So then we just need to multiply by 14. So when you plug it in, you just do 14 sine of 43. 9.5. Are we okay with that kind? Okay. All right, the last ones I think that we're doing, or we'll do one, and if y'all feel like you need to see another one, we can do another one. But they go ahead and they give you a triangle. It says solve the right triangle ABC for all of its unknown parts. And so they tell you in the instructions that we have this triangle here. It's kind of funny because they do this, ABC. They tell you it's a right triangle by marking off C there. And then they have side C, side A, side B. But then what they do is they come inside, and in here they put a beta and they put an alpha. I would just call them angle A, B, and C and side A, B, and C. They're just using alpha and beta as their little symbols to help you, like, solve for what your, like, missing parts are or whatever. So then I would just, this is how I will do it, is set it up like this with whatever they give me for that particular problem. So they tell us in number 56 that alpha is 41 degrees and side C is 10. So then I would come over here and I would write in the stuff that I know. Now, I also know that angle C is 90 degrees because right triangle. I'm sure y'all already knew that. But all right, so what can I do next?
Find angle B.
Find angle B. So how do I do that?
180 minus 90 minus 41.
Yep, so there's 180 degrees total in your triangle. So 180 degrees minus 90 degrees minus 41 degrees is going to give you that third angle, 49 degrees. So then I need to find my other two sides. So I need side A and side B. If you like to write your, like, draw your stuff in your triangle so you know what you already have, like, you totally can do that. Like, this is 41, 49, this is 10. So that way I can just kind of help visualize what I don't have yet. So I don't have side A and I don't have side B. So how might I, or what do y'all want me to use to find those?
Use sine, find side A.
Okay, so sine of what? Sine of 41 is equal to what? A over 10. So I multiply by 10. So A is equal to 10 sine of 41. And again, these will be in degree mode the whole time. We don't use radians in terms of solving triangles.
6.6.
6. All right, now how about side B?
Use cosine of A.
Cosine of A. So cosine of 41 is equal to B over 10. So B is equal to 10 cosine of 41. $7.5. And I would say just go to one decimal place for anything that has a decimal for these ones. If they happen to start you out, like number 57 starts you out with 2, I guess you can stick with 2 if you just really want to, but it doesn't matter. I'm not that picky about it. If you know how to do the problem, I don't really care how many decimal places because it doesn't specify. The other way we could have found the other side, once we had two of them, was the Pythagorean theorem. I think y'all probably know that, but I personally think this is easier. There's less math involved than the Pythagorean theorem has. So, anyways, but there's that. Do we need to see another one of these, or are we okay? Good. Okay. All right, your problems. This is going to seem like a lot, but several of them are like just off the unit circle. Just, I want to make sure that you're familiar with it as much as possible. So, all right, without a calculator. Oh, wait, did I give you problems the other day? Oh, okay, hold on. 3, 11, 15, and 17 are going to be those problems like we did yesterday. Then the stuff that we did today, this is how I'm going to do it. All right, without a calculator is going to be 19 through 27 odd. And I'm going to be honest, if you feel like you've got it down and you don't really need to do that many, you don't have to do all of these ones because I mean, it is a lot. Your calculator problems, so with a calculator, would be 29 through 39 odd. I would say make sure that like you're good with the ones where you have to convert. So like 31 and 37, I would say make sure you are good with those ones because they're either conversions or they're ones that are in radians but don't look like radians, like as in they don't have pi in them. So just make sure you're good with that. And then 41 through 57, I'm going to say every other odd for those because that's kind of the last few things we did. Again, with 41 and 45, like, kind of up to you. If you feel like you're good with those. Like, if you want to do all the odd, you can, but if you feel like you're good, there's not really a reason for you to do that, but just want to make sure you get a good variety in there. So, anyways.